Download this code and get free GPT-4o from codegive.com, link in the description below. Java RMI, Remote Method Invocation, is a Java API that allows objects to communicate with each other across a network. While it is a powerful tool for building distributed applications, there are security vulnerabilities associated with it, particularly when it comes to deserialization and remote code execution. This tutorial will cover some of the common vulnerabilities associated with Java RMI, including a code example to illustrate the risks. Overview of Java RMI vulnerabilities. 1. Remote code execution. If an RMI server accepts serialized objects, an attacker can send malicious payloads that, when deserialized, execute arbitrary code on the server. 2. Insecure RMI registry. If the RMI registry is not secured properly, an attacker can register a malicious object and later invoke methods on it. 3. Lack of authentication. If there is no authentication mechanism, unauthorized users can interact with the RMI services. Example of a vulnerable Java RMI application. In this example, we'll create a simple RMI server that is vulnerable to deserialization attacks. The client can send a serialized object that executes arbitrary code. Step 1, create the RMI interface. Step 2, implement the RMI server. Step 3, create the malicious payload. A simple way to demonstrate a deserialization attack is to use an existing vulnerable library, example Apache Commons collections. However, for educational purposes, we will write a simple payload that executes a command. Step 4, create the client. The client will send the malicious payload to the RMI server. Running the example. 1. Compile the code, ensure you have Java installed. Compile the server, client, and interface code. 2. Start the RMI registry and server, start the RMI registry and then run the server. 3. Run the client, in another terminal, run the client to send the malicious payload. Mitigation strategies. 1. Avoid deserialization. Never accept serialized objects from untrusted sources. Use alternatives like JSON or XML for data exchange. 2. Implement security policies. Use Java Security Manager to limit the permissions of RMI applications. 3. Authentication. Implement strong authentication mechanisms to restrict access to your RMI services. 4. Use firewalls. Limit network access to your RMI services using firewalls. Conclusion. Java RMI provides a convenient way to create distributed applications, but it comes with inherent security risks. The example above demonstrates how a simple RMI application can be exploited through deserialization vulnerabilities. Always adhere to security best practices when developing RMI applications to mitigate these risks.